So today we are going to talk about kinematics. Here we are dealing with those situations that arises due to the movement of an object. So let us begin. First is the types of motion. There are three types that has been divided. Okay, out here this linear is that type of motion when we consider a point object moving in a straight line. A point object moving in a straight line. Okay, and then translatory motion. This motion arises when we consider each and every point out here moving in a straight line. When each and every point of the body is being considered. Then circular motion. When we consider only a point moving in a circle, then that type of motion is known as circular motion. And when we consider a body, okay, and then we consider each and every point in the body moving in a circular motion, then this is known as rotatory motion. And then oscillatory motion, something that is going back and forth. Suppose this point is going back and forth. Okay, if this is going back and forth, repeating its own position, okay, going to the extreme position, coming back to the mean position, again going to the extreme position, coming back to the mean position, this is oscillatory motion. And when this motion becomes, speed of this motion increases, okay, when the speed of this motion increases, then this type of motion is known as vibrational motion. And then we have frame of references, inertial and non-inertial frame of reference. Here is this type of reference is one where Newton's first law holds good. Means this inertial frame of reference is good for those bodies moving in uniform speed, whereas non-inertial frame of references is the one where Newton's first law, okay, that is the law of inertia, does not hold good. Means here the body is accelerating. Then we have motion in one dimension where a point object is moving only either in the x-axis, in the y-axis, or in the z-axis. Okay, in other words, something that has the value of only one coordinate. And then two-dimensional motion where a point object is moving in one coordinate and then another coordinate, something that has the value of both the coordinates x and y. It can be y and z, it can also be x and z. And three-dimensional motion where a point object is going to have the value of all the three coordinates x, y and z, okay, which is the case with 3D, 2D and 1D. And then you have another topic, that is scalar and vector quantities. Scalar quantities are the one that has only magnitude, something that has only numbers, which deals only with numbers, like speed. We do not ask what is the direction of the speed. We ask only how much is the speed. And then vector quantity has the magnitude as well as direction. Okay, here we deal with those quantities that have numbers as well as directions. For example, velocity. We do not only ask how much is the velocity. We ask how much is the velocity and in which direction. Here, in case of your speed, we ask how much is the speed. In case of velocity, we ask how much is the velocity as well as what is the direction of the velocity. Okay, so quantities that deal only with numbers are the ones that comes under scalar, whereas quantities that deals with numbers as well as directions are the one that comes under the vector quantities. And then you have uniform motion in a straight line. Okay, where a body is moving in one dimension and in a straight line. That is, here a body is moving from point O to A. By the time the body reaches from this point O till point A, it is t1, and by the time this body moves from O to B, the time taken for the body from this point to this point is t2. Okay, so OA is the length of x1, OB from here to here it is x1, from here to here it is x2. So what is velocity? It is displacement by time, that is x2 minus x1 divided by t2 minus t1. Okay, x2 minus x1, t2 minus t1, where x2 minus x1 is what? Your AB. Okay, AB is your x2 minus x1. Okay, so this is your body moving in a uniform straight line. And then you have the most important thing that is being asked most of the time in the exam, especially competitive exams like NEET, JEE, is the graph. Let us begin with the graph. So here the graph, out here this is x, this is t, where x is in the y direction and t is in the x direction. So this line that is starting from one particular point, it is not starting from zero. This point indicates that the body is either at rest or stationary. The body is either at rest because it is not changing its position with respect to time. Here time is increasing but not the position. You see, there is no other point out here, only this. So this indicates either the body is at rest or stationary. And then uniform motion. Here you see that it is increasing. Okay, the position of the body is increasing with time. So it's increasing linearly in this fashion. Okay, whatever the position is will be the time. Okay, so hence this graph is indicating that the body is moving with a uniform motion. Now this graph out here, this line is very much similar to the previous one, whereas this and this are not that similar. Out here this indicates that this line is starting from the left of origin. This is the origin and this is starting from the left of the origin, whereas this one, okay, this line is starting from the right of the origin. Uniform but starting from the right of the origin. This is uniform but starting from the left of the origin. And then this one, this graph, okay, out here you see that it is decreasing. Means the body is moving with constant negative velocity. Out here it is decreasing from this point. Okay, slowly it is decreasing. So this graph indicates that the body is moving with constant negative velocity. And then this motion here, you see that by the time the body reaches somewhere here, okay, somehow it is moving with a constant velocity, but the moment it reaches here, there is a drastic increase in the position of the body. Okay, it has moved very far away with respect to time, because this distance is with respect to time. Okay, this is not very far away. Okay, whereas this is a point. Okay, this point and this point are very far away with respect to this graph. This point and this point are very far away, whereas this point and this point are not that far away. Okay, which indicates that the body is accelerating, means the body is moving with non-uniform motion. This is the graph of non-uniform motion. And then after this point with respect to time, it becomes, it is either in rest or decreasing very slowly. Okay, so this graph indicates non-uniform motion. And out here you see that this is the origin, this is the time, okay, this is the position. Now think it properly. We had a graph which was like this, okay, rest or stationary. But can we have a graph like this? Is it possible? No, because if this is being allowed, If this is being allowed, it means it has infinite velocity. The body has infinite velocity. Here, suppose this is time 2 second. 2 second. At 2 second, has the body, reached, if you can see, this is a straight line. Means in 2 second, the body has went somewhere else, which cannot be the case at all. Okay, because it can either be this much, but it cannot be a straight line. It cannot be a parallel line with the y-axis. Okay, this cannot be allowed, because if this is being allowed, then the velocity is infinite. And then we have this graph where a body is not starting from the origin, but from one particular point on the x-axis, on the y-axis, okay, with some position x0. So when it starts from this point and reaches this point, okay, starts from x0, reaches point D. By the time the body reaches T1, it has a displacement of x1. By the time the body reaches T2, it has a displacement of x2. Okay, the point from here to here, okay, the point from C to D, the point from C to D is the one that is going to give us the velocity. Okay, that is the slope of this line. The slope of this line is the one that gives us the velocity. In other words, the slope of the position time graph, the slope of the position time graph is going to give us the velocity, where ED, where this indicates what? x2 minus x1, and this indicates what? T2 minus T1. Okay, hence you see V is what? x2, this divide by this, ED divide by EC, and which is equal to 10 of this angle alpha. Okay, the slope of this line gives us the velocity. So in position time graph of uniform motion, okay, please remember, of uniform motion, the slope gives us the velocity. And then take this particular picture into consideration. Here it has moved from this point to this point. Okay, the body has moved from here to here. So out here, this is the origin. Okay, and it is moving somewhere here. And when I draw a straight line like this, and when I take the area of this CD, C1, D, okay, this area is the one that gives me the displacement. This area is the one that gives me the displacement. So displacement is given by the area under this, under CC1 DD1. Okay, where displacement is nothing but what? Uniform velocity into time interval. Uniform velocity into time interval. And then let us have a look into this particular graph, which is the non-uniform motion. Okay, similar to this, here again, from this point, okay, the body is moving with a non-uniform motion, in a non-uniform motion. Okay, here slowly it starts accelerating. So by the time it reaches x1 within time t1, x2 within time t2, and this line, okay, although this is increasing in an exponential way, but when you draw a line, a straight line from this point to this point, which is AB, is the one that is going to give us the velocity, average velocity. Okay, this line, the slope of this line is going to give us the average velocity. The slope of this line is going to give us the average velocity. So slope of AB, okay, where theta is going to come somewhere here, tan of angle theta is going to be x2 minus x1 divided by t2 minus t1, which is with respect to this two, will be your average velocity. Okay, average velocity is also denoted by one particular v and a dash. Even your average acceleration is also denoted by a dash, not a arrowhead. Arrowhead means it's a vector quantity. The another topic is the instantaneous velocity. Instantaneous velocity means what is the exact velocity of the particle at that exact moment of time. Okay, what is the exact velocity of the particle at exact moment of time? And then you have average velocity, which is going to give you the average value of the entire journey. How much is your velocity within the entire journey? For example, you can move from one point to another within 5 minutes. Okay, then you are moving to another point, but not in 5 minutes. Now you are taking longer time, 7 minutes to 10 minutes. Okay, so when you take the average of all of the velocity with respect to the time, then it becomes your average velocity. So out here, average velocity, okay, here there are certain conditions. S1 is the distance, S2 is the distance, okay, and so on. So S1 by V1, that is with respect to time, it is distance by time, right? So we are writing it in this form, S1 by V1 plus S2 by V2. Okay, this is time, because velocity is what? Displacement by time. Therefore I am writing displacement by velocity for time. Okay, now if the body covers equal distance with different speed, that is S1 S2 is equal to S. If this is the condition, that is covering equal distance, okay, then if all the distance are equal, suppose if you have just S1 and S2, if we are dealing with S1 and S2, okay, divide by S1 divide by V1 plus S divide by V2, okay, S1 S2. If this is the condition, then S, since S is what? Common, okay, equal distance, okay, so this becomes 2S divided by S, 1 by V1 plus 1 by V2. Okay, this is what we are writing. Hence the average velocity is nothing but twice the velocity, okay, V1 V2 divided by V1 plus V2. This is for the case where the body is covering equal distance. Okay, the distance are equal. So, and then another condition is average velocity is equal to V1 T1 plus V2 T2. This is with respect to displacement. Velocity is displacement by time. Here we are replacing displacement. Okay, previously we had replaced time. We had substituted for time. Okay, here we had substituted for time. Here we are substituting for what? Your displacement. Here we are substituting for displacement. Okay, displacement is velocity into time. If now in this condition, previously it was distance was equal. Here the time is equal. Okay, time is equal. Before it was distance that was equal. Here it is time that is equal. So if the time is equal, therefore this V1 V2 plus V2 T2, okay, V1 T1 plus V2 T2 and so on, okay, which goes till Vn will be time T divided by T, because they are equal, right? Hence the average velocity in this case compared to the other case is what? Individual sum of the individual velocities. Here the average velocity is the sum of the individual velocities when it is the case of your equal time. When it is the case of equal distance, the average velocity is what? Twice of that of the the individual velocities. Twice of that of the individual velocities divided by the sum of the individual velocities. Okay, so this is the case with your average velocity. Now acceleration. In the case of acceleration, this will be what? Velocity by time. Velocity by time graph. Okay, here the body is moving like this. There is a change in velocity, because from the definition of acceleration it follows whenever there is a change in velocity we have acceleration. Okay, it is increasing similar to the previous cases. Take this line. Okay, here how much is V1 with respect to T1, V2 with respect to T2. Okay, so this by this is going to give you the average acceleration. This by this is going to give you the average acceleration. Okay, the slope of line AB from this graph is going to give us what? Average acceleration, where this angle theta is what? BC divided by AC, V2 minus V1 divided by T2 minus T1, delta V divided by delta T is equal to average acceleration. As I told you, average acceleration is also denoted by a straight line okay, over the given quantity. Similar to your instantaneous velocity is instantaneous acceleration. That is, what is the exact acceleration of the body at that instant of time? For example, 2 seconds, how much is the acceleration? 3 seconds, how much is the acceleration? Okay, instantaneous acceleration means at the exact given period of time, how much is the acceleration. So here you see delta t tending to 0. And if we are talking about very small quantities means at the exact, if it is exact moment of time, therefore time has to be very, very small. Hence dv by dt, dv dt. And then you have another topic, that is equations of uniformly accelerated motion, where v is what? U plus at, s is the displacement. Okay, here v is the final velocity, u is the initial velocity, a is acceleration, and t is time. Here s is the displacement or the distance. All quantities has their own meaning. And then v square is your final velocity minus the initial velocity is equal to twice as. Okay, so these quantities are very important for solving some numericals. You are very much familiar with this particular equations. Okay, here this equation, this can also be written in the form of g in this way: v is equal to u plus gt with respect to gravity. S is equal to ut plus half gt square, and v square minus u square is equal to twice as. Okay, this is going to be your gravity. So out here this gravity, whether depends upon the sign of this gravity, depends upon whether you are moving in the upward direction or you are moving in the downward direction. If it is whether you are going against the gravity or with the gravity. Okay, depending upon this, it is either negative or positive. Then we have another important topic, which is vectors, something that has magnitude as well as direction and is denoted by an arrowhead. Here a is one vector and b is one vector. Okay, and when I join them, when I combine these two vectors, okay, then it becomes what? This is the tail of the vector, this is the head of the vector. So when I combine this head of the vector with the tail of a, combining head of b with the tail of a is going to look somewhat like this. Okay, head of b with the tail of a. And then to find the resultant, because these are two vectors. Okay, if the two vectors are acting upon any object, if there are two vectors acting upon any object, then we need to find the resultant. Okay, this is going to be the resultant, which is nothing but the sum of a plus b. The sum of a plus b is nothing but the resultant of these two vectors. Okay, these two vectors are the action and this is somewhat like a reaction time. Okay, so then you have something known as triangle law. There are two types of law in vector which are very important, so which tells us about the resultant vector in triangle form as well as parallelogram form. If we do the necessary calculations out here, Qn is the line that is being joined from here to here, that is a perpendicular to OP. Okay, Qn is the line that is perpendicular to OP. So extending with respect to this perpendicular line, okay, is ON. So when we do the necessary calculations out here, we find that this resultant from O to Q, okay, this resultant from O to Q is what? A square plus B square, okay, plus twice AB cos of angle theta. A square plus B square, okay, plus twice of AB cos of angle theta. Out here, this tan beta, this is your beta, angle beta is given by B sin theta, and divide by A plus B cos of angle theta. This becomes B sin theta, okay, by doing the necessary calculations becomes B sin theta, okay, and then A plus B cos theta. Now let us have a look into the parallelogram law. So out here it has the same result. Here even the same thing is taken, that is draw a perpendicular line to OP. Okay, out here the vectors are in this form. Our vectors are, previously it was in this form, okay, where the resultant was this. Again, in the case of parallelogram, we are not changing anything with the vectors. The only thing is that here head is connected to the tail. Okay, here head is connected to the tail, whereas here in this case the tail is connected to the tail. The tail is connected to the tail, and this diagonal that is going through, okay, this diagonal that is going through is the resultant of the vector. Even here you see, here this is the one that is giving the resultant. Similar to this is this case, this diagonal is giving the resultant. So out here the resultant is what? A plus B twice AB cos theta. Tan of beta is B sin theta divided by A plus B cos theta. This is the similar result that we get. Now here there are certain things that we can do when both are acting in the same direction. Means A and B are acting in the same direction. A and B are acting in the same direction. If this is the case, then cos theta will be what? 0 degree. Okay, cos theta will be 0 degree. If cos is 0 degree, okay, if cos of angle theta is what? 0 degree, this is square, this is square. If cos of angle theta is 0 degree, then the resultant is what? A plus B whole thing square. This will be cut down with the root, then you have A plus B. From here we see that beta is what? B sin theta. Sin 0 is what? 0, therefore beta is 0. And then another case, when both are acting in the opposite direction, A is on this side, B is on this side. If both are acting on the opposite direction, then cos will be what? On the, this will be 180 degree. Okay, then it is what? Minus 1. Therefore A minus B whole thing square. It will be A minus B. Resultant will be A minus B. Okay, so beta will be either 0 degree or 180 degree. When acting right angles, okay, when acting right angles, that is if both are acting at right angles to each other, A and B, then the resultant is A square plus B square, and beta is what? B divided by A. B divided by A, because sin 90 is 1 and cos 90 is 0, therefore you are left with B and A. Then you have subtraction of vectors. So if you have one vector A in this way, okay, look into the direction, it is like this, and you have B in this way. Okay, on subtraction, please remember, on subtraction the direction changes. This is plus B, this is plus B, and if I want to take this minus B, then it becomes like this, minus B. The same vector, okay, if you change the direction it becomes minus B. Hence this is A, this is A. Here you see this is not changing, whereas B, it was like this. Okay, it was like this B, but here minus B is this. Okay, hence the resultant is A minus B. So for B minus A, what you do to get B minus A? Change the direction of A from this side to this side. Okay, and then you have another topic, that is component of vectors, where the vectors get divided into two parts. Okay, the sum of which is going to give you the original vector. The sum of which is going to give you the original vector. So out here, take this triangle into consideration. Here, with respect to cos of angle theta is what? X divided by R. X divided by R. Therefore, in the X direction, here, therefore, in the X direction, what is the component of vector? It is R cos theta. So in the X direction, the component of your vector is what? X is equal to R cos theta. And here, with respect to sin theta, it is what? Y divided by R. Hence, the component of vector in the Y direction is what? R sin theta. Okay, this is the component of vector in the Y direction. This is the component of the vector in the X direction. In the X direction, it is cos theta. In the Y direction, it is sin theta. So out here we see that the y component is taken as a sine theta and the x component is taken as a cos theta, where this is going to be the resultant a, whose sum is nothing but this plus this. Okay, so out here the component along the direction of theta, which is along the direction of theta, is a cos theta, and the component perpendicular to it is a sine theta. Therefore resultant is written as r square is equal to r square sine square theta plus r square cos square theta. Okay, r is equal to r is equal to root over r square sine square theta plus r square cos square theta. Suppose if we have two components, okay, two components 3 and 5, then the resultant can be written as root over 3 square plus 5 square. Okay, and then another topic we have is the unit vector. Unit vector is a quantity that has same direction, same nature, but the only thing is that magnitude is 1. In this case, for example, let me take the vector of force. If this is the force vector, okay, vector of force having a magnitude of 10 Newton, then the unit vector of this force is also going to have the same direction, this way. Okay, unit vector of force is also going to have the same direction in this way. The nature is also the same. The only thing is that if this is 10 Newton, since the magnitude is only 1, therefore it is going to be 1 Newton. This is unit vector and it is expressed in this form. A vector is equal to n a cap. Okay, a unit vector is mostly denoted by a cap in this term. Okay, and then the unit vectors along all the three coordinates. For example, out here this is one vector a. A vector a has been drawn, okay, having all the three coordinates x, y and z. Then the unit vector along x-axis. In x-axis it is ax, a suffix x is the x-axis. Therefore the unit vector along x-axis is I cap, along y-axis is j cap, and along z-axis is taken as k cap. So from here, if I want to calculate the magnitude of a, is going to be nothing but root over ax square plus ay square plus az square. And if I start drawing some angles, this angle alpha is the angle between this vector a and ax. This angle beta is the angle between a and ay, whereas this angle alpha is the angle between a and az. Okay, so ax is going to be what? A cos alpha. Ay is going to be a cos beta. Az is going to be a cos gamma. Hence a square will be equal to what? A square. Okay, everything under bracket. Okay, whatever it is, just substitute from here in this formula. You are going to get this. This are going to get cancelled out. You are left with what? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. So this tells us that the sum of the squares of the direction of cosine of a vector is always unity. The sum of the square of the direction of cosine is nothing but unity. And then we have another topic, that is projectile motion. When a body is moving in this fashion, this fashion, okay, then this type of motion is known as projectile motion. And there are two types. One is horizontal type, one is vertical type. So here there are certain components and certain equations that are very much important to remember. If a body is moving from this point, it has been thrown with respect to an angle theta. Okay, it is going in this way, reaches this point. This point is known as h. Okay, height. This point is known as h, height, and it goes this way, reaches here. This point to this point, this length is known as range. Okay, this point to this point is known as range. From here, okay, from here to here is known as height, and then the time taken for the body to move from here till here and then to the ground is known as time of flight. So these are the three important relations that needs to be understood in order to solve some numerical problems, okay, and becomes a little important with respect to your NEET exams. So out here, u is the velocity of projection, theta is the angle of projection, and g is nothing but the acceleration due to gravity. So if we have a look into the formula for time of flight, it is 2u sine theta g, and for height it is u square sine square theta divided by 2g. Range, okay, range is u square divided by g sine 2 theta. Out here you see you get the maximum range at the angle of 45 degree. If you throw it at 30 degree, it will fall here. You throw at 60 degree, it will fall here. So your angle to get the maximum range, okay, to obtain maximum range while throwing a stone or anything, has to be 45 degree so that it can cover more range. So for any given velocity, if we use the 45 degree of projection, then the range is maximum. Then we have one more equation, the equation of projectile motion, which is given as y is equal to tan theta x minus g divided by 2u square cos square theta x square. Okay, this equation is the equation of projectile motion, and this equation is somehow similar to the parabola. Here it is x, here it is x square. So y is equal to ax plus bx square is nothing but specifying the shape of the parabola. Then lastly, you have one more topic, that is circular motion. When a body is moving in a circle, when a point or a body is moving in a circle, okay, so when you have a point moving in a circle, there are certain things that changes. We know that when a body moves from here to here, it is going to, cover some distance, and also displacement is going to occur. Now in this case of circular motion, when it goes in a circle, not in a straight line anymore, when it goes in a circle, then here, if a point is moving from here to here, okay, the velocity of this particle is going to be somewhere here, okay, and by the time it reaches here, the velocity will be somewhere here. Okay, in this way, the velocity when it reaches here, the velocity will be somewhere here. So this theta is nothing but your angular displacement. This theta is your angular displacement. Okay, hence omega, that is your angular velocity, is what? Displacement by time. So angular displacement by time in this case of circular motion, okay, d theta by dt. And then alpha is denoted as angular acceleration, where alpha is given as omega by t, that is angular velocity by time, d omega by dt. So the direction of the acceleration is towards the center. The direction of acceleration in case of circular motion is towards the center, and this type of acceleration is known as centripetal acceleration. Okay, the acceleration that is needed to keep a body in circular motion, and is given as v square divided by r. So out here, apart from the angular acceleration, there is one more acceleration that comes into play. Okay, that is, suppose if a body is going in a uniform speed, when a body is going in a uniform speed, it is going to have uniform speed in circular motion. It is going to have angular centripetal acceleration. It is going to have centripetal acceleration. But then, if an acceleration is acting at the tangent, if an acceleration is acting at the tangent to this circular motion of the particle, okay, at, then this type of acceleration is known as tangential acceleration. So if you have both the acceleration, this will always be present. Okay, centripetal acceleration will always be present in circular motion, but tangential acceleration, it can be present, okay, or it cannot be present. So suppose if centripetal acceleration is present, also tangential acceleration is also present, then the body, if the body is turning and if its speed is increasing, then it has both the acceleration, such that, you know, if a body is turning, while turning it is going to have centripetal acceleration, and if the speed is increasing, means it has both centripetal acceleration plus the tangential acceleration. Hence the net acceleration is nothing but root over centripetal acceleration squared plus the tangential acceleration squared. Then we have one more thing, relation between linear and angular, that is linear velocity acceleration and angular velocity and acceleration. So in terms of linear and angular, the relation between linear velocity v and angular velocity omega is given as v is equal to omega r. And then in case of linear acceleration a and angular acceleration alpha, the relation is given as a is equal to alpha r. So in the diagram, if it is given, okay, if this type of symbol is given, okay, a dot is there over a circle, this means that the body is coming out towards you, okay, towards you. It's like an arrow coming, okay, arrow, if it is coming towards you, it is pointed. When it is going away from you, it has a type of a, you know, cross out here. So when it is going away from you, it is denoting a cross. When it is coming towards you, it is denoting a point. So when it is coming outside, it is denoted by this point. When it is going inside, it is denoted by this cross. Okay, and then centripetal acceleration, as I told you, it is given as what, v squared divided by r. Okay, there are certain things that should be noted down. For example, slope of distance time graph of a uniform motion along a straight line gives the velocity of the body. Okay, that is slope of distance time graph. Slope of velocity time graph of a uniformly accelerated motion at an instant represents the acceleration of the body at that instant. Okay, we are going to understand all this when we do some examples. So area enclosed by velocity time graph with time axis is equal to the distance traveled by body for the given time. So area enclosed, if you have a graph, velocity time graph, and a certain area is being enclosed by this graph, then this area inside this graph is going to give you the distance traveled by the body. Okay, the area under this graph, in a VT graph, the area under this graph is going to give you what? The distance traveled by the body. So let us have a look into this particular example. From the position time graph, find the average velocity from 1 second to 3 seconds. Here this is the position time graph. Okay, this is position, this is time. So what are they saying is that they want you to find the average velocity from this graph. Okay, out here this is a linear graph, okay, increasing uniformly. This is a uniform motion, so it is increasing very uniformly. Hence out here, if it is a uniform motion, you already know, in order to find the average, okay, in order to find the average, what you do, you take these 2 points, right, and then what you do, you take the slope from here. Okay, with respect to this angle, you take the slope, you take delta x and delta t. Okay, so delta x is what? x2 minus x1 divided by t2 minus t1. So out here, with respect to this, if I take with respect to this, then this is what? How much? In 3 seconds it has covered 45. In 1 second it has covered 15. So t2 is 3 seconds in this case, and t1 is how much? 1 second. Therefore the answer that I am going to get is 15 meter per second. Okay, 15 meter per second. In the case of uniform motion, you need not need not need to do all these things, because it is covering equal distance, okay, equal distance in equal interval of time. So even if you take only this line, okay, only this much, then how much it has, the average velocity is 15 meter per second. Okay, if it is a uniform motion. If it is a non-uniform motion, then you cannot do this. Okay, you have to take it in this form. If it is a non-uniform motion, and if it is a uniform motion, okay, that is equal distance and in equal interval of time, you can do this. And then let us look into another question. A body starting from rest accelerates uniformly along a straight line at the rate of 10 meter per second square for 5 seconds. Okay, it goes, at the rate of, accelerates at the rate of 10 meter per second square for 5 seconds. It moves for 2 seconds with uniform velocity. After 5 seconds, for 2 more seconds, it moves with uniform velocity of 50 meter per second. Okay, here it is indicating that after accelerating for 5 minutes, the body has a speed of how much now? 50 meter per second. Okay, you have to understand these things from the question itself. After moving, okay, after 5 seconds, within 2 seconds more, okay, it has a speed of 50 meter per second. Then it retards, means it is, it is decreasing, okay, decreasing the speed. So then it retards uniformly and comes to rest in 3 seconds. So here it is how much? 5 seconds. It accelerates 2 seconds, uniform velocity. Okay, velocity is not changing. And then 3 seconds it comes down. So here this is how much? The total is 10 seconds. Okay, draw velocity time graph of the body and find the total distance traveled by the body. Okay, so you have been asked to draw the velocity time graph of the body and find the total distance traveled by the body. So out here, in drawing the velocity time graph, you have to remember that how much is this? 10. So in the x-axis, it has to be 10 seconds, or the x-axis has to be more than 10 seconds. Okay, so 10 seconds is the minimum. Okay, so the graph is going to look somewhat like this. They have mentioned the body accelerates till how much? 5 seconds. Till 5 seconds it is going to accelerate till point A. So out there in the question, they had also mentioned one thing, that after 5 seconds it is going to go in a uniform motion, and the speed also they had given how much? 50 meter per second. So this is a straight line with respect to 50 meter per second. Okay, and then they have mentioned after this much, okay, after 5 plus 2 seconds, the rest of the 3 seconds, the body is going to retard. That is, it is going to decrease its velocity. So it is going to come till 10 seconds. So this will be your graph for the given question. Okay, and out here, as I told you, that the area under this graph is going to give us what? The distance covered by the body. So out here, how much is the initial velocity? It is 0. Final velocity is what we have to find out. Acceleration is 10 meter per second square. That is for this motion from 0 to A. It is how much? 10 meter per second square. Okay, from 0 to A it is 10 meter per second square. It is given in the book from 0 to 5 seconds. Therefore time will be how much? 5 seconds. Okay, time will be 5 seconds. Use this equation. Here this is 0. You get how much velocity? Final velocity is what? 50 meter per second. So with respect to 50 meter per second, okay, you draw a line from here to here till 50 meter per second. Okay, because here they are saying that after this point the body moves in uniform velocity, means this is the point where you should take the final increase in the velocity. Okay, that is the final velocity, so becomes 50 meter per second. And then after that, as I told you, the total distance traveled by the body during the motion is going to be given by what? The area under this trapezium. So the area of the trapezium is given as half of OC plus AB, okay, into AA1 into AA1. So the answer in this case is going to be 300 meters.